Hi guys, welcome back to my channel Pirai. In the series of Zoho interview question, today we are going to see about a question called smallest greater elements in whole array. Given an array A of n length, we need to calculate the next smallest greater element for each element in the given array. If the greater element is not present in the given array, then we need to fill -1 and 7 zeros corresponding at that in this place. Fine. So it is not a big deal, but the logic behind it is a big deal. Okay, fine. So let us see an example. In this example, first of all, for this 13, what is the smallest greater number, which means its next greater number present in this array? None, right? Because there is nothing which is greater than this 13. So I will be filling with the corresponding value they have given. Fine. Now listen this carefully. Now it is important. It is 6. Now what are the elements that are greater than 6? There are 3 elements, 7, 12 and 10. But what is the immediate next element? It is 7. So I will be taking this 7 here. Okay. Similarly, for this 7, what is the greater element? It is 10. Okay, and for this 12, what is the greater? It is 13. For this 10, what is greater? It is 12. For this 2, what is greater? It is 6. That's why I have constructed this output array. Fine. So how to do this? So it is basically from this example itself, we can build a brute force logic. So what is the brute force logic for this? Initially, I will be taking a resultant array. Okay, a resultant array of size n, which means of size is 6 elements. So I will be taking here also for 6 size. Okay, fine. Now I am just iterating here. What is here? It is 13. Now again I want to iterate over this all elements. So I am going to iterate 13. Whether 13 is greater than 13, no. Whether 6 is greater than this 13, no. Whether 7, 12, 10, 2, nothing is greater than 13. So I will be giving the value that is given defaultly. Okay, now again I will be traversing to here to 6. Okay, now again I will be traversing from here. Whether 13 is greater than 6, yes. So I will be taking 13. As of now, my answer is as of now it is 13. Okay, it is not sure. We may get any other possibly smallest greater number. Okay, again here 6, no, 6 is not greater than 6. 7 is greater than 6, and also it is less than this 13. Can you understand this? 7 is greater than 6 but less than the 13. So I will be updating this as 7. Okay, now again I will be going here 12 is greater than 6 but not less than 7. So I don't want to update anything. So come to here 10 is also greater than 6 but not less than 7, and come to here it is 2 is not even greater than 6, so leave as it is. Now similarly I will be going to this 7, then 12, then 10, then 2, and I will be updating here. Like here comes the answer is 7 for this 6, right? So I will be updating here 7, then 10, then 13, then 12, then 6. So this is going to be my brute force approach. Hope you understand this. Now tell me, what is the time complexity of this brute force approach? It will be O of n square, because I am just iterating over the array elements for each and every elements. Again I am going to iterate over the all elements in that array. Fine. Now what is the space complexity? It will be O of 1, because the resultant array don't come into my count of the space complexity. Fine. Whether I can optimize this approach. Okay. So basically we are just want to know what is the immediate greater element, right? To know the immediate greater element, it is easy if we have sorted it. Can you understand this? Yes. If I sort the current array, then it is something look like, first of all 2, then 6, then 7, then 10, then 12, then 13. Whether I want to sort the given array? No, because the given array is the original array from which we know whatever element will be going to the result, right? See here for this 13 in the resultant I have given what? The default value. For the 6 only, I given the 7. If I sorted the original array, then the positions will be collapsed. Okay, so that's why I will be taking another auxiliary array space. So this is the original array, and I will be taking a auxiliary array space, and I will be storing all these elements into this and sorting it. Now I will be taking this 13, right, while traversing. Okay, for this 13, I want to find what is the next greater element, immediate next greater element, right? But absolutely here nothing, right, on its right side. So we will be taking the resultant array, and I will be giving the default value. Fine. Now while going to this 6, what is the next element to this 6? It is 7, right? So I will be giving this as 7. But whether this approach is correct? No, because I will be telling you this clearly, okay? Because if the given values are unique, then only this is applicable. But in our question, they didn't state that it is unique, which means can be a duplicate. For example, if it is like 6, okay, then here also 6 and another here also 6, okay, 2 6 are present in the given array, for example. Then I will be taking this 6 and I will be saying that the next to the 6 is again 6. That's absolutely wrong, right? So while handling with these kind of edge case, we will be going with the binary search approach. I will be telling you how to do the binary search approach in a correct way. Okay, we will be taking this 13 initially. We will be taking this 13, and in our resultant, the first index will be corresponding for this 13, right? Now I will be going on with the binary search approach on the auxiliary array and checking whether anything that is greater than the 13 or not. Okay, so initially here is my L and here is my U, and where is my mid? My mid is something like here. Okay, what is the formula? It will be L plus U divided by 2. So 0 1 2 3 4 5, then 5 plus 0 divided by 2, which is equal to 2, the integer division. Okay, also we can give a formula like L plus U minus L divided by 2 also. That's absolutely fine to avoid the upper bound of the integer limit. Fine. Now mid, whether this mid 7 is greater than this 13. No, which means we want to move further right side. So I will be making my L to mid plus 1. Now again, what is a mid? Mid will be now 12. Okay, now whether this 12 is greater than the 13? No, it is not. So I want to go further right side. So I will be making my L pointer to move here, the mid plus 1. Now what is a mid? Mid is 13 itself. Whether 13 is greater than 13? No. Now I want to move further right. If I move further right, which is mid plus 1, then L is overlapped this U. Okay, always the L should be less than or equal to U. It cannot go greater than U, the upper limit. Okay, in that time I want to stop and I will be decide that there is no further answer for this, and I will be giving a default value. Hope you understand this. Similarly, now I am going to execute for this 6. Okay, I will be quickly writing this. Okay, so 0 1 2 3 4 5. Now for this 6, similarly I will be taking this as lower limit, this as upper limit, and here is my mid initially. Whether 7 is greater than 6? Yes, it is greater than 6, but we are not sure that 7 is the correct answer. We may get any other better answer if I move to the left hand side, right? So I will be taking the answer as 7 initially. Okay, and I will be moving my upper limit to mid minus 1. So I will be going here. Now what is my mid? My mid will be 2. Whether 2 is greater than 6? No. So now I want to move my lower limit to mid plus 1. So lower limit comes here. Now what is mid? Mid is 6. Okay, whether 6 greater than 6? No. Then I want to make my lower limit go mid plus 1. Now my lower and upper limit are exchanged or overlapped. So at this point I want to stop and I will be updating my corresponding indices 7. Hope you understand this. Similarly, I will be also giving you for this 7 only, and the rest of them, these 3 values, you can do it by yourself. Okay, so for this 7, again let me redraw the array. 2, 6, 7, 10, 12, 13, 0, 1, 2, 3, 4, 5. Now it is for 7, right? So initially L will be here, U will be here, and mid will be here. Now what is the mid? It is 7. Whether 7 is greater than 7? No. At this point, I will be making my lower limit to mid plus 1. Now what is the mid? Mid is 12, right? 12. So 12 is greater than 7. So I will be taking my answer as 12 initially. Okay. And I will be moving to the left hand side. I will be making my U pointer to move mid minus 1. Okay. To make sure that if there is some other answer which is a better answer. Okay. Now it is what? Mid is 10. Whether 10 is greater than 7? Yes, it is greater than 7. So update this as 10. Can you understand this? And make my upper limit to mid minus 1 so that we may get any other possibly best answer. Now see here, L pointer is overlap the U pointer. So stop here and the answer will be 10. So 10 will be updated here. Similarly, for this all 3 elements, I will be updating here. Okay, fine. So this is the binary search approach, and the time complexity will be efficiently used as n log n, because for sorting it will be n log n, plus the traversal and the binary search approach is also n log n. So n log n plus n log n, which is approximately equal to n log n. Okay, and the space complexity will be O of n, because we are taking an auxiliary space here for the sorting purpose, right? This auxiliary space plus the merge sort algorithm. The inbuilt sorting technique will be using the merge sort algorithm, and that merge sort algorithm is also taking an auxiliary space of O of n. That's why it is an efficient approach of time complexity of O of n log n and space complexity of O of n. Fine. Now let us see the code so that it will be more clear. See here. First of all, I am taking let me explain here first. Okay. First of all, I am taking num, which means the auxiliary space I have discussed in the drawing explanation. Inside that, I will be cloning the given array. Okay. And I will be sorting the num. Fine. Now I will be traversing over the array, the original array, and I will be taking each and every element and I will be giving to a function. That binary search function will be giving me the next smallest greater number. Okay. So here I will be updating that into my original array itself. Okay. You can also take the resultant array, or you can also update in the original array. That's your wish. Okay. However, the resultant array will be not going to be in a space complexity. Okay, fine. Now for this, I will be going to this function. Let me explain this function. In this function, I will be taking a lower limit as 0 and upper limit as length minus 1 and answer as the given default value. And then while lower limit is always less than or equal to the upper limit, I will be going and finding the midpoint of the lower limit and the upper limit point. Now, if the current mid element is greater than the element we want to find, then what should I do? I should be storing that current mid value into my answer and reducing my upper limit to the mid minus 1, such that I will be getting, I may get a possibly a smallest greater element, right, which will be the best answer for the current element, right? Else I want to just make my lower limit to mid plus 1, such that I will be getting a greater value for the current element. Okay, and finally I will be returning the answer. It is for a dummy return. Okay, it is for sorry. The answer will be holding either this default value, or this answer will be holding the mid value, whatever. Okay, and this answer will be returned and it will be called here and stored in the current value of the ARR, that array. Okay, and at last I will be returning that corresponding array of the resultant. Let me submit it. Yes, it is submitted successfully. To know about these kinds of algorithm, just go and watch my YouTube channel. And if you really like this video and subscribe to my channel. Don't skip any videos in the Zoho series because all the videos are helpful when you are going to attend the Zoho interviews. Thank you.